Today we're going to investigate Newton's second law. At GCSE level, we normally write Newton's second law as being F is equal to ma, but I'd like to add two things to it. I normally write a small letter r here to represent that this is the resultant force on an object. The other thing I do with it is I put two arrows, and that implies that if the object has got a resultant force in a certain direction, the acceleration of the object will be in the same direction, and that is from Newton's second law. The practical today is to find out how does acceleration vary with F, or in the second part, how does it vary with M. Portions, you expect to get a graph like this, and this is our little investigation for today. We are going to do that using a frictionless track. What am I going to vary? I've got an option of varying either the mass or the force. The object that I'm using today is this, just a trolley cart, right? So my trolley has got a certain mass, m. I can either change m by adding more weights on top, or I could change the force, the resultant force I'm pulling it with. And for that, I'll need a pulley and I'll need weights to be attached, which is what I'm going to use. So remember this, okay? So I've got my pulley connected, a smooth pulley that doesn't do put a lot of friction in here. So I'm going to change the force using that. However, I want to measure acceleration. How do I measure acceleration? Well, I could effectively work at the velocity here and the velocity there, the distance it travels, and use my suvac. There are plenty of possibilities for that. But I want to be very accurate in this experiment. And for that, I'm going to use light gates. So this is a light gate. I'm going to use two. How does a light gate work? A light gate works using the principle that it's got a beam here of infrared. And the moment that you cut through it, it starts the timer for you. Okay? And you can see that it's still thinking that actually something is traveling through it. And the moment you go through, it's off. On, off. And then this is then connected to your data logger. So again, students, it's very important for you to differentiate between data logger and light gate, data logger, light gate, data logger. Now the data logger can be adjusted to any setting. It can measure time, it can measure velocity, it can even measure acceleration. So for simplicity today, I'm going to tell my data logger to measure the acceleration between 2 points. I'm ready to start my experiment. So this is generally better done with two students. One is holding the weights, and when the other person is ready to let go. Notice that the weight should have been under a bucket, so if it does fall, then the weights don't injure someone else, but there's no one in the room except for me, and I'm more protected. So 3, 2, 1, and let go. Good. So effectively, as this object has moved through this distance, this will now work out my acceleration. I know my acceleration, and I know my force I'm pulling it with. So what's the force? Here's the other step that students tend to forget. These are my masses. So these are 10 grams, and I've got 1, 2, 3. So that's 30 grams. Do you know how to convert 30 grams of mass into weight or into the force? Okay, the second part of the practical is for students to investigate how does the mass of the trolley affects the acceleration, keeping the force constant. So what I'm doing, I'm effectively not changing the tension here. So the force is remaining constant. I'm going to change the mass of the trolley. And how do I do that? I could use weights. So I've got my 10 gram, I put it in here, or 20 grams, and I pin it. And I'm going to do this experiment in the same way that I did earlier. Let go. Great, that's it. So now I can measure the acceleration by changing the mass. So two parts of the experiment. One where you change the force and one where you change the mass, but both measuring acceleration. And the relationships that you should get will be like this. If you're changing the force, which is the tension through the weight, you'll get a direct proportion. And if you're changing the masses by adding weights to it, then you'll get an inverse relation. Thank you.